Right, let's go back to this exercise 23.05. Okay, but I will explain only a few questions, especially for the odd number. 2, 4, 6, 8 and 10. Okay, only 5 questions from this 23.05 in delta. Okay, so let's start with question number 2. Solve this differential equation by separating the variable. Okay, so actually you have to separate now. Use the separable method. Okay, so first thing first, you have to separate them according to the variables. Okay, so apa yang saya nampak di sini ialah dy equal to 4x dx. And then, so boleh tak kita pindahkan this 4? I don't want to put this 4 over here. Can I bring to the other side? Yes, you can. Boleh letakkan divide by 4 jadi 1 over 4 sini. Tapi I dah mention kan, usually we keep the constant together with the variable. So tak prefer yang ni lah. Okay, so now put the symbol. Right, so they will produce, actually ada 1 di sini, so they will produce y plus c1 equal to 4x squared over 2 plus c2. And usually we keep y as a subject, so therefore they will have c2 minus c1, right, 2x squared plus c, where c equal to c2 minus c1. Okay, sama lah macam jawapan I. Okay, so usually we put y as the dependent variable at the left hand side. Okay, another one. Alright, so over here I have y dy over dx equal to 1 over y. So therefore, usually I put y at the left hand side and then 1 dx, symbol of the integration. Okay, right. So over here you will have y squared over 2 plus c1 x plus c2. Okay, now so over 2 x plus c, where c equal to c2 minus c1. Okay, you nak stop ke sini boleh, but usually we put y as a subject, so therefore you will have y squared equal to 2x plus 2c. Okay, therefore 2x plus c. Okay, because when you multiply constant, when you multiply number to the constant, there's still a constant, so sebab tu kita boleh keep as a c. Okay, doesn't really matter about that lah, unless kalau you wanted to solve the square becomes square root, then you have to keep the 2c, because sometimes you boleh square root the number over there. Okay, tapi it doesn't really matter, usually kita put as a y squared. Tapi boleh tak I nak put as a 2x as a subject? Yes, you can change minus c lah. Ini pun betul. Okay, sebab itulah in delta sometimes you tak dapat jawapan yang sama. Okay, and sometimes, okay, kalau you notice, I keep the y at the left hand side, x at the right hand side. Okay, actually kalau you nak keep c ni sebagai subject, you have to move the x to the left hand side. So sebab tu you akan dapat negative x. Okay, tapi doesn't really matter lah, as long as your answer ni is equivalent to the final answer. Tak ada masalah. Okay, so let's try another one. Right, so question number 6. So I bring the y to the right hand side, and therefore I have negative x dx. Okay, and then put the symbol of integration. Therefore, I have y squared over 2 plus c1 negative x squared over 2 plus c2. Okay. And then over 2 plus x squared over 2 plus c, where c equal to c2 minus c1. And then kalau nak dapat jawapan sama macam delta, you have to solve the 2 over there lah. So therefore I have y squared plus x squared equal to 2c, y squared x squared equal to c. Okay, where c equal to 2c. Number multiply constant is still a constant. Okay. You nak, by the way, you nak stop kat sini pun dah betul. Tapi because we try our best to make it similar to the answer from delta, therefore they produce, you have to move around, you have to move these two to the other side lah. Okay, so question number 8. Question number 8 ni a bit tricky. Tak adalah tricky, actually it's very hard to make your answer similar to the delta answer. Okay, alright, so number 1, change the according to the variable, and then after that put the sign of integration. Therefore integrate 1 dapat y, integrate y dapat y squared over 2, and don't forget to put plus c1. Integrate 1 dapat x, integrate x dapat x squared over 2 plus c2. Okay, y minus y squared over 2. Sorry. Minus x squared over 2 equal to c, where c equal to c1 and c2. After that, you have 2y minus y squared minus 2x minus x squared equal to c. Okay, stop kat sini pun okey dah. Alright. So, tapi kalau you nak dapatkan sama macam ni, okay, you have to use backward. Kenapa maksud saya backward? Because kalau you expand, if you expand this answer, you will have x squared plus 2x plus 1 plus y squared minus 2y plus 1 equal to c, x squared plus 2x plus y squared minus 2y plus 2 equal to c. Okay, if you notice, apa yang bezakan kita dengan final answer ni ialah sign. If you notice, you dapat plus 2y, but over here negative 2y. If you have negative y squared, but I have positive, actually apa yang bezakan dia ialah I move my answer after I integrate, I move my x to the left hand side. But for this final answer from delta ni, they move to the right hand side. Okay, so actually tak ada issue. As long as you boleh, number 1, you boleh integrate separately according to the variable, and then you boleh susun in a line, as long as you boleh come up with this general solution. What's the general solution just now? Without any derivative lah, makna tak ada lagi dy over dx in your equation. Okay, so macam mana nak prove our answer is correct or not? Ini for your additional information saja. How to make sure your answer is correct or not? Actually, okay, kita kena gunakan, kita panggil sebagai implicit differentiation. Implicit differentiation. Method dia mudah. When you see, kita nak differentiate kita nak dapat with dy over dx, meaning every term ni kita differentiate with respect to x, right? Every term ni kita differentiate with respect to x. Okay, tapi for implicit, when you differentiate y with respect to x, you akan dapat dy over dx, you akan dapat produk dy over dx. Contoh, okay, let's take a look this equation. Macam mana nak provekan dapat sama macam ni? Okay, now so differentiate 2y with respect to x, you akan dapat 2, but you have a product dy over dx. differentiate y squared, you dapat 2y. Again, you dapat produk dy over dx. But untuk differentiate x, you differentiate x as usual. Differentiate 2x, you dapat 2. So tak ada produk dy over dx ya, because you differentiate with respect to x. And then differentiate x squared, you dapat 2x. Differentiate constant, dapat 0. Okay, now jadikan dy over dx as a subject ataupun you group according to the variable. So therefore kat sini dapat 2 minus 2y. Okay, and then I move this negative 2x to the other side. So 2 plus 2x. Okay, and then I put the dy over there as a subject. So therefore kalau you notice, saya dapat balik 2 minus 2y. If I solve, I have 1 plus x over 1 minus y, which is sama macam soalan asal. Okay, so actually jawapan kita ni betul, cuma different sign. Okay, it's not necessary untuk dapatkan final answer macam delta. Delta ni I not really sure macam dia boleh come up with this answer. Maybe dia boleh dia come up with the ada different punya calculus part. Tapi since your leveling is not necessary lah untuk fahamkan that method, so I think enough untuk you stop kat sini saja. As long as your final equation tu, which is your general solution without any derivative. Okay, so you boleh gunakan implicit ni. Ini for your additional info. When you differentiate y, you akan dapat produk multiply dengan dy over dx. But when you differentiate x, you akan differentiate as usual without multiply with the dy over dx. Okay, alright. So this question number 10. So if I move this y to the other side, it's become 1 over y dy, and then 1 over 4x cube dx. Okay, kalau you not really sure, you boleh play around dahulu, which is you bring up dahulu. So 4x cube dy over dx, and then kat sini dapat y dx. Tapi kat sini you ada different, right? Variable x, tapi you ada silap. Tersilap sekejap. Okay, you wanted to differentiate, you wanted to integrate x, tapi respect to y, something wrong. So from here baru you jadikan the in this method, in this form lah. Alright. Okay, next baru kita integrate. So integrate 1 over y dy, integrate 1 over 4x cube dx. Okay, kat sini you akan dapat ln. Kat sini you akan dapat ln. But over here is 1 over 4. Bring up negative 3. So x negative 3 plus 1 over negative 3 plus 1 plus c2. So simplify further. Ln y plus c1 1 over 4. 1 over 4. Kat sini akan dapat negative 1 over 8. Negative 1 over 8 x squared plus c2. So ln y equal to negative 1 over 8 x squared plus c. C ni is the constant of c2 minus c1, and then I don't want to put this ln, so therefore I have to change. This become exponent negative 1 over 8 squared plus c, and then y equal to exponent negative 1 over 8x squared times k, where k is exponent power of c. K ni actually exponent power c lah, right? Tapi kalau nak gunakan method from the page number 402, sebab tu nanti you akan dapat ky. Kat sini akan dapat ln ky, and the rest sama juga. Okay, it's up to you lah untuk pilih yang mana yang sesuai. Okay. Right, so this question number 23.05, from number 11 to number 15. So I choose only the odd number 11, 13 and 15. So number 11. Okay, so therefore I have over here is, I move this y, so therefore 1 over y dy 2x dx. Okay, this time I nak gunakan ln k, ln k. Okay, kat sini I akan dapat integrate 1 over y dy integrate 2x dx. So I know when I integrate 1 over y akan dapat ln ky. Kat sini dapat 2x squared over 2. Okay, tak perlulah letak plus c. Tak perlu letak plus c because you dah put a constant when you integrate 1 over y kat sini. Ini best dia. Tak perlu letak plus c. Kan tadi kan kita banyak, you have an additional working solution. Tapi untuk yang this time, I don't want to use the ln kc. Okay, x squared. And then as simple as ky equal to exponent of x squared. Okay. Kat sini kena careful. Okay. Kalau you pindahkan, dapat over k. Is it? Over k. Tapi constant, 1 over constant is still a constant, right? So sebab itulah boleh letakkan k saja. Ini different dia. You kena careful. Sebab tu I not really encourage. Okay. I not really encourage you untuk gunakan. Better you gunakan plus C1 plus C2. Therefore you nampak ni pattern dia. Actually dia datang from K over there. K actually 1 over K. Sebab kita gunakan K kan. So it's not that different lah. Okay. Jadi careful tu je. Tapi kalau exam nanti you letakkan jugalah y equal to 1 over K exponent x squared. Saya still accept. Saya still accept. Okay, now number 13. Alright, so first thing first, you have to apply the law of index, which is kat mana? Over here lah. When you add the power, meaning you punya base ni sama, which is you multiply dengan exponent of y. Baru you boleh pindahkan. Alright, so exponent y dy exponent of x over 1 plus exponent of x dx. Okay, put the symbol of integration. Okay, but over here you have to using the substitution method. Kat sini tak ada issue. Exponent, you integrate the exponent, masih dapat exponent. Put plus c. Okay, tapi kat sini kena gunakan substitution method, which is I let you. Okay, kita buat sama-sama. For integration exponent of x over 1 plus exponent of x dx, we let u as the function ada denominator. So du over dx, integrate differentiate 1 0, differentiate exponent, dapat dari exponent. Put the dx as subject sebab kita nak substitute dx with the in term of u. Alright, so therefore your integration over here become du over exponent of x. So the remaining is only 1 over u du. So integrate 1 over u is ln u. Tapi sebab kita applykan constant tadi, so kita letaklah ln ku, gunakan method ini, ln ku. So automatically tak perlu letak C1 and C2. Yes, tak perlu letak C1 dan C2. Okay, just letakkan saja the result of integration. Right, so let's proceed. Sini akan dapat ln modulus of 1 plus exponent of x. So kita dapat produce k 1 plus exponent of x. Okay, right, so macam mana nak dapat sama macam answer di sini? Oh, by the way, silap sikit. Ini kalau pindah dapat 1 over 1 over. So kat sini adalah negatif. So ni akan dapat negative. I'm so sorry. Okay. So in order to dapat sama macam sini, so you have to move this one to the other side. So it becomes 0 equal to ln modulus of k 1 plus exponent of x plus exponent negative y. Cuma kat sini dia letakkan exponent of y in front lah. Sorry, my mistake. Actually pindahkan dia dapat divide 1 over exponent of y. Pindah dapat exponent power of negative y. Okay, I'm so sorry. Okay, number 15. Okay. First thing first. By using the separable method, kita separatekan dulu lah. So therefore, you have to move this one become divide 1 over cosecant dy square root of x dx. Okay, kalau masih ingat lagi, secant is actually 1 over sine. So 1 over sine. And then itu kan siap 1 over 2. Okay. So kalau you solve in this one, so you boleh bring up, right? So it's become sine y dy x 1 over 2 dx. Okay, because ni 1 over sine y. So therefore you boleh bring up. So automatically yang the rest akan hilang lah. Sebab ni 1 on 1 kan. So sine y dy equal to x power 1 over 2. Baru you integrate. So integrate of sine y dy integrate x 1 over 2 dx. So integrate sine negative cos, function copy. Okay, because kalau sepatutnya you kena divide with by differentiate the function, but differentiate y is a 1, so sepatutnya tinggal hanya negative cos y plus c1 x power of 3 over 2 over 3 over 2 plus c2. And then kalau you notice, final answer dia letakkan positive, is it? So meaning dipindahkan to the right hand side. So c1 minus c2 3x3, sorry, this is 2. Okay, over 2 over 3 plus cos y. So 3c equal to 2x 3 over 2 plus 3 cos y. 3c is a constant, which is c. 2x 3 over 2 plus 3 cos y. Okay, nak stop sini boleh. Or maybe you nak tukarkan dia jadi set macam ni. Okay. Alright, number 17. Before we end our video, last but not least. Show that dy over dx equal to negative x over y. Okay, yang ini you have to use, we call as the chain rule. Meaning, first thing first, you have to come out with dx over d theta. So given x equal to cos theta plus sin theta, dx over d theta in differentiate cos negative sin theta, differentiate sin is cos theta. Y pula given cos theta minus sin theta. Dy d theta is differentiate cos negative sin theta. Differentiate sin is cos theta. So dy over dx equal to dy over d theta multiply d theta over dx. Yang kita ada dy over d theta, so that is not an issue. Just copy from whatever you have over here. Multiply. You have dy d theta over dx, but you have is dx over d theta, meaning you have to flip. It's become like this. Baru you combine negative sin theta minus cos theta over negative sin theta plus cos theta. Negative sin theta minus cos theta ni samalah macam negative sin theta plus cos theta divide by negative sin theta plus cos theta. So sin theta plus cos theta ni sama macam x. So negative x. Negative sin theta plus cos theta ni samalah macam y. Cuma they put the sin at the back, cos in front. So sama. It's proof. Okay, how about B? Write a general solution for the differential equation. Meaning you have to use a separable method. Okay, so B. Solve for the dy over dx equal to negative x over y. So therefore definitely you akan dapat y dy negative x dx. Integrate y squared over 2 plus c1 negative x squared over 2 plus c2. After that y squared over 2 plus x squared over 2 c, and therefore yang tinggal ialah plus x squared equal to 2c, y squared plus x squared equal to c. Right? Okay, next, the third question. The third question, show that the curve defined by this pair of parametric equation is one of the solution found in part B. Okay, yang this one actually, kan tadi kita dapat y squared plus x squared equal to c, right? Okay, actually as simple as you substitute y and x over here lah. So yang akan dapat kat sini ialah cos theta sin theta squared cos theta sin theta squared. Okay, expand, yang akan dapat kat sini ialah cos squared theta minus 2 cos theta sin theta plus sin squared theta plus cos squared theta plus 2 cos theta sin theta plus sin squared theta equal to c. So if you notice 2 cos sin theta you boleh minuskan dengan plus 2 cos theta, so hilang lah. So the remaining is only 2 cos squared theta plus 2 sin squared theta equal to c. So ada satu identity for the trigonometric, cos squared theta plus sin squared theta equal to 1. So kalau notice kat sini you boleh factorize So it's become 2 cos squared theta plus sin squared theta equal to 1. Equal to c. Ni c soalan asal So 2 times 1 equal to c, therefore c equal to 2. So the solution for c found in part B is equal to 2. Okay. So dia kata sini ialah satisfy the equation when c equal to 2, meaning dia akan general solution awak akan solve if c equal to 2. Okay. Alright, so that's it for this video. So let's continue in the next video. Thank you.